How can optimization can help Indonesia diversifying their economy and reducing their reliance on natural resource and also the commodities? Okay, guys, so in this thought-provoking video, we will delve into the crucial question of how Indonesia can effectively diversify their economy and also reducing their reliance on natural resource and the commodities. Through the lens of the optimization, we have a problem-solving approach using a mathematical format, and we will exploring how Indonesia can allocate its scarce resource and also maximizing their economic potential. So let's uncover the optimal solution for Indonesia's economic development so we can envisioning a future where the manufacturing sector will take the center stage, creating value and also propelling nation towards a more sustainable and also diversified economy. Okay, guys, so let's jump up into the code. Okay, first thing first, before we are going to the code, we need to understand what we need from the library in Python. In here, we are importing at least three library. For first thing first, we are importing NumPy, we are importing Pandas, and also we are importing the linear programming from the scipy. These libraries will providing us the function and the tools for mathematical calculation and also linear programming optimization without we are need to design it by ourselves. Okay. Next, after we are importing the necessary libraries, the next thing is we are creating the objective function, okay, that we call object. It's represent the value added coefficient for the extractive like manufacturing and also the heavy manufacturing sectors. The coefficient indicate the contribution of each sectors to the overall value added in the manufacturing sectors. The objective is to maximize this value. And then the constraint matrices are created using the list of lists called LHS inequality. Each sublist is represent a constraint. The first sublist represent the capital constraint. The next is represent the label constraint. The next thing we are also considering the energy constraint and also the minimum share of the extractive sector. This constraint will ensuring that the available resources are allocated appropriately. And on the side values for the inequality, they are defined by RHS inequality. It contains the available capital, the labor, the energy values, yeah, reversing from the first LHS equation. LHS inequality. And also we are adding the minimum extractive sector here with the share of 20% of the total value added. Okay. After that, maybe it is easy because we are using Python, guys. Okay, the linear programming function here is we are calling it using the to solve the linear programming problem because the approach we take is linear programming. We will take the objective function, the constraint matrix, and also the right hand set value as the input in this linear programming. The method parameter is set to high. What is that? This is indicating the use of high solver for solving the problem in the linear programming. Okay, the next thing is the solution to the linear programming is stored in the OPT variables. It contains the optimal values for the decision variables that maximize the objective function. This value will represent the optimal allocation of resources to the extractive, to the light manufacturing, and also the heavy manufacturing sector. Okay, and then the optimal solution will be printed using the print function. The resource allocation values for the extractive, like manufacturing and heavy manufacturing sector, are displayed here. We will showing the quantities allocated to each sectors. Okay. And then the maximum value added of the manufacturing sector is also printed. It represents the optimal value of the objective function that achieved by the solution. The value indicates the maximum value that can be generated by the manufacturing sector given the available resources and also the constraint. And now let's talk about the output. First thing first, the optimal allocation resource is displayed here. We are showing the quantities allocated to the extractive, like manufacturing, and also the heavy manufacturing sectors. In this case, we are allocating 100 units to the extractive sectors, 80 units to the light manufacturing sectors, and 60 units to the heavy manufacturing sectors. This value representing the optimal resource allocation strategy for maximizing the value added in the manufacturing sector. Okay. The next thing is the maximum value added to the manufacturing sector is print. Of course, it is 100. The value represents the maximum achievable value of the objective function. It is indicating the highest level of value creation in the manufacturing sectors, giving the available resources and also the constraints. And these output results provide a valuable insight into the optimal resource allocation strategy for Indonesia's economic diversification. And yeah, guys, by effectively allocating resources and maximizing the value added in the manufacturing sector, Indonesia can reduce its reliance on natural resources and also the commodities by fostering a more sustainable and diversified economy. And yeah, the upper result highlight the potential for economic growth and also the prosperity by embracing these optimization strategies. Maybe it is simple, guys. Okay, we are just using the linear programming, just importing the scipy here. Okay. And so, what can we conclude, or what are the takeaways, or maybe the lesson learned from this video? Okay, we just witnessed the power of optimization to understand Indonesia's path to economic diversification and also to reducing its reliance on natural resources and the commodities. Okay, by allocating resources strategically and also maximizing value added in the manufacturing sector, Indonesia can forge a new trajectory towards a sustainable and diversified economy here. Okay, so let's embrace this vision of the progress where innovation, efficiency, and also conscious resource allocation will drive Indonesian economic growth, will propelling the nation towards a future of prosperity and resilience. Okay, so join in this one. Okay, you can try any kind of the other optimization method by using the Python. Okay, it will be fun if we are approaching the problem that kind of the big problem with the mathematics. Turns out diversification is only a linear programming problem, and we can just solve it by calling one function, guys. Okay, hopefully this video will give you some insight, and we can always learn something new every day. That's all from me for today. See you in the next video.